So for our example of momentum dealing with angles and components, I picked something that is a little bit of a simple example, but we have a before and after situation. So we've got a bowling ball moving towards some pins. It hits one of the pins, and then the ball flies off in one direction and the pin flies off in another. Sort of like before it's going straight, and then afterward it splits into a V, which is what you could probably imagine. So we'll see if mathematically that's what works out. So to set all this up, you set up your before situation and your after situation, collect all your information. And beforehand, we have the ball moving at 8 meters per second, and the pin is standing still, so 0 meters per second. And then afterwards, you can see that the pin is headed off at 15 meters per second at an angle of 85 degrees from the direction the ball was moving in the initial position. So I've drawn that for you. And then the ball, we're going to imagine it's heading off in the opposite direction. That makes sense mentally, at some angle. And we set it all up, but then we realize that before and after, mathematically, you've got to start dealing with some angles. And so we're going to collect up all the motion in the x direction first. And it really doesn't matter. I just started with x, just as long as you pick one and stick with it, and then go back and pick up the other. So before, in the x direction, the ball is moving straight. In a straight line. And then afterwards, we're going to have the sum of the two velocity components in the x direction. So here's the ball moving beforehand. Here is what happens afterwards. We don't know anything about the velocity. And here's the x component of the pin's motion. You work through the math, and then you get 14.8 meters per second for the ball in the x direction. And then we get the y direction. We do something similar. Now, think about it, this is the beginning. There was no motion across for what we would call the y direction if we called the path x that the ball was taking. So there wasn't any motion in that direction. So nicely, that's 0. And then afterwards, we have the momentum of the ball in the y direction and momentum of the pin in the y direction. And plugging things in, there's the ball, there's the pin, there's the component for the pin right there, and we get that the ball is going negative 2.54 meters per second in the y direction. So it's going in the opposite direction as the ball, which is what we kind of thought would happen. Now we have to get the final answer. So we have to put the components back together. Use Pythagorean theorem to do that. And then you use tangent to find the angle. Be sure you set things up correctly. To find the angle, we've got the negative 14 here, or the positive 14 here, and the negative 2.54 going that direction. It's going to give us a negative angle. Once again, this looks like what we would expect to happen. The ball comes in, they collide, the pin heads off that way, the ball heads off that way, which is what we would think. And here's our final answer right here. We get just about 15 meters. We get 15 meters per second at minus 9.7 degrees from the original ball direction. So there you have it. That's how you work the momentum with collisions and angles.